All right. Hi, everybody. My name is Michael DeSa. I'm going to be talking today about monitoring methodologies. So this talk is broken down into two parts. So the first part, we're going to talk about the read and use monitoring methodologies and how you can kind of apply them to your particular use case. And then we'll talk a little bit about what maybe you should do if those don't quite apply or have a reason through those types of situations. And then part two, we're going to dig into a bunch of different metric types and events and try to design a schema with a read or use methodology in mind. We'll be creating some Flux queries throughout that process. Cool. So part one, monitoring methodologies. So I'm going to start with what is monitoring, right? It's a term we throw out a whole bunch, but it really is observing a process or the quality of something over a period of time, right? And it's a system where you collect metrics and events about other systems. It allows you to observe things that are happening so that you can diagnose and understand the state of the thing that you care about, right? Your application or your server, things like this. So why is this so difficult? It turns out that there's a near endless amount of things that we could monitor about any one system, but it's not immediately clear which of these data would be signal and which would be noise. And so in general, people just kind of like throw the whole kitchen sink into their system and then end up frustrated when there's a lot of data there and they're not exactly sure what value it provides to them. So the goal of this talk is to kind of maybe give you a few signals that you can pay attention to and give you like a heuristic or a couple heuristics that you can use to define those signals. And then we're going to go through and we'll write some queries in Flux that help you get insight or achieve some business goal with those signals. So the question now becomes, what should I monitor? And the thing that always comes up whenever I do a schema console is I ask, well, what do you want to know about your system, right? And there's kind of like a couple categories. The ones we'll be talking about today in particular is like, why isn't my system performing the way that I expect it to? Or what is the experience of my system? Somebody who is interacting with it or some other code that is interacting with it. Like, what does it feel like to interact with my system? And so we're going to use the use and read methodologies to kind of reason through this. And so if you're not familiar, the use methodology was developed by Brendan Gregg and is used to identify performance problems in a system. And so use stands for utilization, which is how much time that the resource was busy. Saturation, which is the degree to which that resource is busy. And then the errors, which are just any errors that are associated with that particular resource. And then, that's a lot of words and they're like very similar, like utilization, saturation, they kind of feel similar. So let's maybe drop down to an example and help think about this in something a little bit more concrete. And so imagine that you're running a pizza shop, right? Saturation would be how many orders you have received but have yet to fulfill. It's like your backlog, right? You have these things that are kind of just waiting to be fulfilled. And then the utilization is how many pizzas that you're like actively cooking. And then the errors obviously are any mistakes that you make throughout that process, right? So it could be on the order side, or you might burn a pizza or accidentally mess up an order, things like that. So cool, great analogy, but what do each of these various kinds of signals mean, right? So suppose I have lots of errors, right? Well, if I have lots of errors, that means that I'm not getting the most performance that I could be out of my system. Maybe I'm having to redo work, or there's just things that are fundamentally broken. And so, having lots of errors ends up meaning that you are going to be slower, or you're not being optimal. Okay, that's fine. So what about maybe if I have really high utilization, like 100% utilization? In that case, another thing we'll observe is that whenever new work arrives, so if I get a new order, we're going to see that my kind of saturation just keeps ballooning, right? Because I'm 100% busy just trying to make pizzas. So that means when the next one comes in, I can't actually fulfill the order, and it just goes into my backlog of pizzas that I need to make. This typically means that there's a bottleneck in my system. So maybe I need more pizza ovens, or maybe I need more people to work on those pizza ovens, things like that. It's just, there's some bottleneck somewhere in the system that is preventing me from being able to fulfill all of the orders that I have coming in. So another place of high utilization that you want to be conscious of is about the 70% limit. That's usually about where you want to run for maximum efficiency. And the reason for that is that beyond 70% utilization, you start to see like exponential effects in your saturation, right? So if it bursts up temporarily at that 70% utilization, you're going to see a massive spike in your saturation, and then you're going to spend a lot of your time just trying to catch up, and so you're not going to be performing as optimally as you can be, and so your saturation will just kind of start ballooning. So you want to pay attention if you're looking at utilization. Like anything above 70 is usually a signal that there's something wrong. And then there's a use case or a situation that you might not think of readily, which is to have really high saturation but low utilization. And this can come up because we typically look at utilization over time. And suppose that, you know, I was at 100% utilization for a 5-minute window, but I'm looking at utilization over an hour window. It's going to look like I wasn't very utilized, right? But what can happen is that when I was in that short period of 100% utilization, that I had this massive backlog of things that kind of built up. And so I'm highly saturated, even though I'm not 100% utilized. And so this also tells me a little bit more about the problem that I'm working on, right? It tells me that these things are burstable and that I might want to allocate more things to handle that burstable load rather than kind of the steady state things. So cool. The heuristic or the process that you use to apply the use method is to figure out what are all the resources in your system. These don't have to be just physical resources. They can be software resources like mutexes or thread pools, or they could be like, you know, my memory or my CPU. And what you do is you kind of just itemize them all, and then for each one of those resources, you look at the utilization, the saturation, and the errors associated with these things. So, okay, cool. But what if I don't have a performance problem, right? What if it's, you know, I want to know what it's like to kind of, what the experience of my service is. And so there's another method, which is called the RED method, which is developed at Weaveworks. I'm pretty sure that's true. And it's rooted in Google's 4 golden signals, which comes from the Google SRE book. And the whole point around the RED method is to help you understand the experience of your system. And you can typically use these to set service level objectives, like I want to be 99.99% available to handle any request that happens, and I will do so in less than 1 second. And you can make these commitments with people consuming your service and use that to kind of drive requirements of your system. And so the RED method, RED stands for request rate. Doesn't have to just be request, but typically it is around a request response kind of system. You look at the request rate, which is the count of the occurrences of a request. Then you have the error rate, which is the frequency of errors. And then you have the duration, so how long each request took you to do. And frequently you look at things like the average duration or the 99th percentile or things like this. Cool. So if we imagine this like a pizza analogy again, right? And we've tried to apply the RED method to it. The pizza rate, so the frequency that I'm receiving and fulfilling orders, right, would be the rate of my pizza shop. Then I would have the error rate, which is how many times I make mistakes making a pizza. And then duration, right, is how long from the time that a pizza is ordered to the time that it's delivered does it take. And you kind of might be asking yourself, like, you know, why would this be a thing, or how does this really apply to pizzas, right? But I'm sure everybody's pretty familiar that there's pizza shops that have like we guarantee your order in 30 minutes or less, right? And so they could apply this like SLA that they have to make sure that all of their orders get fulfilled in 30 minutes or less, applying and looking at this RED method. And if you have high errors, right, in this RED method, then you're going to see either you're missing orders or you're not picking up your phone. And this is going to lead to like a negative experience of your service, right? People aren't going to be happy. they can't get their orders in, or they can't get them serviced within a time frame that they'd really like to. Or if you have a really high request rate and your error rate's pretty, nominal, not particularly alarming, you might want to consider increasing the amount of pizza shops you have, right? Or increasing your amount of pizza ovens, how many requests you can kind of reasonably fulfill in a period of time. It just gives you an idea of what the steady rate of these things are. Cool. And so for applying the red method, the heuristic, right, is you just want to go through for each operation that you'd like to understand or each request, and you track the rate of that thing, the duration of it, and the errors. So, well, what if I don't have a performance problem or an experience problem? And in that case, I would kind of encourage you to develop your own methodology, geez, that was a hard word to say, and reason from first principles about your system, right? And so I would guide you to try to have a specific idea about what it is that you'd like to understand about your system, and then either to construct or discover metrics in your system that let you answer those questions. And it's a little bit of a cop-out, but that's typically kind of the way that I would run a schema consult. Cool. So in part 2, we're going to talk about monitoring in practice. And this is going to be like, okay, so we talked about these high-level concepts. Like, how do I actually make this a reality? And to do that, we're going to talk a little bit about data types in monitoring applications or in monitoring systems. And I'm going to put them into like 2 main categories, and then we'll do a little bit of work to compare and contrast those data types and their implications on your query patterns. So on one hand, there's these pull style metrics. So these are typically things that are stored inside a system, so either in memory or on disk somewhere. And then periodically, you have another component that reaches out and scrapes those values, right? So you store the state internally to the service, you keep that value around, and then you kind of scrape it periodically. And then there are what I'm going to call push style events, which are kind of like fire and forget metrics, and they usually capture like some kind of point in time value. And the key thing here is that they're like non-aggregated values. With a pull style, I might keep track of the state of the thing inside of my system. In a push style, I see the value and I send it off to my monitoring system to then kind of handle and deal with. So in pull style metrics, there's 2 big categories and then some others. We'll talk about the others later. I don't want to quite get into those just yet. But the big 2 are counters, which are like a monotonically increasing value. And it's used to track things where you'd like to understand the rate at which an operation happens. And so, if you're tracking like the request rate or the acquire rate for a lock or things like that, you'd want to pay attention to a counter, or you want to use a counter. And gauges are slightly different. They're things where the value can kind of go up and down. So if you think about maybe monitoring CPU usage, you do that with a gauge because your CPU can be heavily utilized or it can go down. So another example, if you wanted to track the number of concurrent requests that are happening in your system, you could use a gauge to do that. And again, as I mentioned, we'll talk about the other 2 in just a moment, or the other 2. Cool. And so for push style events, there's, in my mind, kind of 2 categories. There's like raw events that contain no other information other than the operation or that the event has happened. And you can kind of like string together common events using shared metadata. And so when I think about raw events, I typically think of like Google Analytics or implementing an eventing system kind of on the UI to capture marketing funnels in a front-end application or things like that. They don't have to exclusively be 2 things like that, but that's commonly where my mind goes. And then you have kind of like derived events, which I think of as like tracking individual HTTP request latency. So like you can think of like a derived event as like something that is the event plus some actual data, right? So like it's that there was an HTTP request and that HTTP request took 30 seconds to happen or 20 seconds to happen. It's kind of like a point in time gauge value. Cool. So yeah, I know a lot of words again and not a whole lot of concepts. And so what we're going to kind of do next is talk a little bit about actual examples of these data. I'll put them in line protocol, and then we'll show kind of Flux queries that correspond to each of the use cases. And I want to call out in particular that I'm going to do most of these things in a red style, but they apply just the same. They apply the same way that they do to the use. But a lot of the example that we'll be doing is kind of going through things in a red style. And before we get into that, I want to add like a quick note about Flux here. And so this is going to be, we're going to have more or less this Flux query that we have here as like the base for everything else that we're going to be doing. And I want to talk a little bit about why I'm doing the thing in this base. So suppose I have the measurement CPU as a single tag called host equal to A, and then two fields, usage idle and usage user. If I run this base Flux query for the CPU measurement, like I have here, I get back this like denormalized table. So the thing I want to call out in particular, notice how there is, instead of there just being one single line of line protocol, I get two tables, two value records in a table, or two rows in a table when I issue this query. And the reason for that is we're doing this kind of like internal transformation so that the field and field name ends up being a column on the data that comes out of it, right? And so I personally struggle with this format since it doesn't match my ingest, and I feel it could be a little bit tricky. And so in a lot of the queries I have, not all, but a lot of them, you're gonna see me instead use a package from the Flux library called V1, which allows me to do a pivot of that table so that the record that I get when I query the data looks very similar to the data that I've written in, right? So notice how we have that comment that has CPU host equals A, usage idle, usage user, and note how the record we have on the bottom of the screen there is more or less exactly the same as that line that we wrote in. So I'm going to use this pattern a lot in the following examples, so just keep that in mind. So what we're going to do now is kind of just go through each of those different types of metrics, and then I'm going to show some examples of what, when you write Flux queries, what that ends up looking like. And I'm going to start with derived events because I think they're the easiest to reason about and write queries for. And at the tail end of this, I'll talk about some ways of compare and contrast each of them and how to reason about which one you should use and in which circumstances. And again, just kind of reiterate, I'm going to do this all in kind of a red style context. We're tracking request rate, errors, and duration, but the same concepts apply for use. I'm just kind of focusing these examples on red just to keep it simple. Cool. So we're going to start with derived events. So what we're going to institute or construct is an HTTP event that has we'll have a measurement called HTTP event that has three tags, the host that it happened at, the ID of the request, and the status of the request, right? So 500 or 200. And then as a field, we're going to have how long that request took. And we're going to go through and construct red for each of these things. So it's really simple for derived events, right? There are 4 things that happened here. All we have to do is count them. And what that's going to look like when we write our Flux query is that base Flux query that we had where we just turn the data into the shape that we'd like. And then we're going to say group, which is going to put everything into a shared kind of table. And then we're going to apply an aggregate window, which just windows the data up into 1-minute chunks. And for each one of those chunks, it's going to count the duration nanoseconds, right? Which is exactly what we said and conceptually when we were going through that data, which is great. Cool. What about when we want to now count the errors, right? So this one is just as simple, right? We just need to identify events that have an error status, and then we'll count those. And so when we do that, the only thing that changes about our previous query is we just have this filter up top that checks for statuses that are in the 400 or 500 class so that we can denote that it was an error. There might be some arguments here about whether or not you should treat 400s versus 500s differently. Personally, I group them together, and they mean slightly different things when you do that, but I think it's still a good information of kind of what is happening to your system or what issues users are running into in your system. Cool. That's all simple. And then what if we want to do like conceptually the same thing for duration, right? So we want to know what was the average duration. We could do things like percentiles or 99th percentiles. To keep it simple for now, let's just do averages, even though averages in reality can be a bit misleading. So in this case, conceptually what we're going to do is we're just going to fetch all of those duration nanoseconds, we'll sum them together and then divide, right? Luckily, we have a function called mean in Flux that will just do that exactly for us. So the only thing that is different about this example from the others is that instead of doing count, we do mean, right? And so that's kind of why I usually feel like derived events are the simplest. Is the query is really the only thing that changes about this query is the thing that you're filtering for and the function you apply to it. There's not a whole lot of other things going on here. So I think it makes it really easy to think about. There are downsides to events though, particularly that, it puts a lot of burden on your metric system, since if you're having hundreds of thousands or millions of these things, it doesn't quite scale. But something you want to always kind of keep these trade-offs in mind whenever you're building your system. Cool. So I started with derived events because I think they're the easiest to reason about. What do we want to do if we say have raw events instead? And so again, in the context of this like red method HTTP API monitoring. And so for raw red events, what I think we would do is we would have a metric called HP event that has two pieces of information on the request start, which is just the host and the request ID. And then it'd have a single event record stored as a field that says request started. You don't have to store this as a field. A field is a string value. We could have done something with the measurement or tag if we wanted to, but I felt conceptually it was a little bit easier to kind of think about an event stream of a series rather than to optimize this for performance. In the real world, you'd probably make this the event be like a bool, and you would have the type of event as either the measurement or as the tag. So one of the things I want to call out here is that you kind of have these pairs that are all linked together with a request ID. This is going to be super important when we go to try to join these events together on kind of figuring out some things like the duration in here. So another thing to kind of note, right, is we actually don't have any duration information here. We don't have any numeric information. We just have that the events are firing. And so we're going to kind of go through and apply the red method to it. So here we would count either the request started or request finished. I personally would pick request finished just because it has some information about the status, which we can use to then compute the errors. And so conceptually in this one, we just find all the finished requests, we count them, and then we're good to go. And so again, we have the same kind of base Flux query. We filter for the event, which is event finished. We group them into the same common window, and then we apply the count, right? So exact same concept as what we had done in the previous example. And in the case of errors, we do the exact same thing. So we just look for things that are non-200 status, count those, and send those on to the rest of the pipeline. So the only thing that changes here is we add this check for non-200 statuses. Cool. So the part where this gets a little bit more sophisticated is when we want to extract the duration between the request start and request finished from a raw event, right? And so we're going to walk through kind of a sequence of steps of how you do this. So the first thing that you want to do is to identify finish and start events. And to do that, we're going to have our same kind of base query. We're going to store that in a variable in Flux. And then we're going to grab two pieces. We're going to grab the start by looking for request started. We're going to have the finish by looking for request finished, which is perfect. So we got our two events. Now that we have the two events, we're going to join them on their request ID. so that we can then take the difference of those fields, of their timestamps. And so to do that, what we're going to say is we join the tables start and finish on request ID. So joining the things together on a request ID. And then we're going to do this little hack here on the bottom. It's not super important, but more or less what we're doing is we're going to make the timestamps on the data that we joined together the timestamp of the start column, right? So we have, kind of going back, we have these two events. So we're joining them together, and we're going to make the new time on our record, we're going to make that T0, or the first timestamp in the sequence of events. Cool. So when we do that, we'll get our data in a form that looks more or less like this, where we now have something that's very similar to the derived events, not quite, but very similar, to where we have the HTTP event that has 3 tags, which is host, request ID, and status, and then 2 fields, right, which are event start and event stop. There'll be a couple other pieces of information on the table, but conceptually, that's what we'll be dealing with. And so from here, what we need to do is then compute the deltas of each of those timestamps. And to do that, we're going to use the map function in Flux, and we're going to just do the difference of the finish time with the start time to give us the duration between those in nanoseconds, which is great. We're going to do one thing to convert that to seconds. So we'll just divide by 1 billion to turn nanoseconds into seconds, which is great. And then we're back to really the same thing that we were doing previously, which is we have the durations, we just need to compute their average. And to do that, we could put everything into the same group. We window it over time in 30-second chunks, and then we compute the mean of the duration in seconds. Cool. So raw events are a little bit harder to work with when we start looking into things like durations. Pretty easy for rates and errors, but durations gets a little bit more complicated. What happens when we want to look at maybe poll style metrics? And the thing about poll style metrics, particularly poll style counters, is that you usually don't care about the actual count. What you're really looking for is the relationship between the count and like the rate that it's changing at, right? And so if we were going to apply a poll style counter method to trying to do red style monitoring, the way that we would construct that is we'd have something like a measurement called request, then 2 tags, one for the host and one for the status. I want to call out here explicitly, note how there is no request ID. The reason for that is we cannot identify individual requests. This is a big downside, right? So you can't look at individual requests. However, it ends up saving you a bunch on the compute side, so on the query side, and on the storage side, you don't have to keep around this extra tag. But you do lose a little bit of visibility into individual requests. And you have to start looking at things in aggregate. So we have our measurement and tags, and we have 2 fields. Each of those fields are the duration sum, which is a counter that represents the sum of all of the durations. So if I have one request that takes 10 seconds and then another that takes 5 seconds, my duration sum would be 15 and my request count would be 2, right? So it's just 2 counters that kind of go up by different values. Request count goes up by 1 each time, and duration sum goes up the duration of the request each time. So, cool. How do we now find the request rate for this counter? And to do that, what we're going to do is just take a look at the deltas of the request count. And to do that, we use this function difference in Flux, right? So conceptually what it does is it just looks to its neighbor and then subtracts its neighbor from itself to get the value of the thing. I want to call out here, there's 2 functions in Flux that you can use for this type of thing. One of them is difference, the other one is derivative. I personally like using difference just because it keeps everything as integer values, and it makes it a little bit easier to not have to like think about the denominator when you're taking a rate. So whenever you do a derivative, it'll like divide it by some kind of unit, whereas a difference just tells you the difference from the values that you collected, rather than like dividing that and getting like a per second value. You just get the value per collection interval. Not too big of a deal. But I do want to call out this non-negative here. So what can happen in counters is, say for whatever reason, the thing that's tracking the state of this counter resets. And when it resets, it goes from a very high value to a very low value. And what that results in is you get a negative value when you compute the difference. And so what we're saying is we don't want any negative values, so we only want the non-negative values from this thing. So once we do that, we take the difference, which is great. That gives us our delta request count. And to get the rate, all we have to do at this point is apply we have to just sum all of the values for that counter up, right? So it changed by 3, it changed by 4, we want to know it changed by 7. To do that, we're going to add a group to put everything into the same group, and then we just apply the sum to total count, which just has the count of all of the requests. Great. And then what about for errors? So we did the exact same thing that we did for rate, but instead we just check for the non-200 class errors, or not 500 or 400 class errors, which is great. And then what about for duration? So this is where it gets a little bit more complicated, and in the real world you would do something slightly more sophisticated, but let's say, for example, we just want to understand, in this case, the average duration, right? And so conceptually what we need to do is we need to figure out what was the size, how much duration was there in total, and how many requests were there, and then just divide those by each other, right? So compute the total duration, compute all the requests, and then just divide those two values by one another. So we're gonna do just that. Cool. And so I want to call back again to this normalization example. I'm actually going to take advantage of this table being denormalized to make this query a little bit simpler. I could split it out and do 2 separate queries, one for the request rate and one for the duration, and then join those together. I'm not going to do that because I think it's a little bit simpler. The query gets a little bit simpler. You just have to reason through this normalized kind of table. Cool. So to do that, you can think about the field name really being a tag on your data, right? So where we had 1 line for each of these previously, we can think about it as 2 lines of line protocol with the same field, one that stores the duration sum and one that stores the request count, right? And so kind of just a little bit of a shift in your mind how you think about the problem. And from there, the first thing we're going to do is exactly what we had done in the previous 2 examples, right? So we're going to filter for the fields where that a field is either a duration sum or a request count. We're going to take the difference, and then we're going to sum those differences together to give us the sum of the rates, which is great. So that'll get us to something that looks kind of like this, where we still have field as a duration sum. So we still have 2 tags that are called field, one that stores duration sum, one that stores request count, and then we just have the delta values kind of stored. And so the next thing that we want to do is we want to sum together things that have a common field. So we want to sum all of the duration sums together, and we want to sum all of the request counts together. So to do that, we're going to group by the field and then apply the aggregate on top of that, right? So we split it into the individual fields and apply the aggregate. Once that's done, we now have the sum delta, right? The sum of all of the deltas for duration and for the request count. We're gonna finally do that pivot to put everything onto the same line, right? That pivot being the V1 fields as calls. And then that's gonna give us data that looks like this, where we now have the duration and the request count. So From here, it's really easy, right? We have the total duration and total request count. We can just divide those values by one another. And we do that using a map, and where we say the average duration is the float of the duration sum divided by the float of the request count. In reality, you'd probably want to be a little bit careful here because request count could probably be 0, right? So no request happens. So you'd want to handle that case in particular. But in this, I don't think that's necessary for this example. Cool, so that was for averages. I want to call out two more advanced poll style metric types here that you would probably want to use if you wanted to start to understand like quantiles, like 99th percentile or things like that, not just averages. But more or less what they are is just a sequence of counters and sums that let you understand how many of a thing have taken place and how much data has built up in each of them. And so summaries are used to kind of get a cross service. So I have like a distributed system, right? And I want to know what is the 99th percentile across all of my services, not just in a particular like implementation or instance of a service. And so it, yeah, as I said, creates a sequence of counters, and you can kind of use it to compute approximate quantiles. The other one is a histogram, where instead of exposing those like those raw primitives, it exposes the quantiles, so you can know things like, for this individual service, the 99th percentile of this instance of this service was 10 seconds, or something like that. And so these are very useful when you want to start to understand things that are not just the average duration, but they get a little bit more complicated. And so each one of these generates like, I think like a fairly large number of metrics. I'm not totally sure of the exact number. I think it depends on a couple other factors. Cool, so that's a lot of information, and we didn't really quite answer like, well, what should I use? And whenever I try to answer this question or think about this question, it really comes down to the cardinality that you have and the wherever these metrics are being generated and the available resources, right? So if I'm in a server and I want to do HTTP API tracking, I probably don't want to do I probably don't want to do things or track things that have really high cardinality, right? Say I want to have an idea of each session or each request ID, and I want to track that in a poll style metric. What's going to happen is my memory requirements are going to balloon a whole bunch because I need to track every single instance of this metric that kind of comes up, right? So like, say if I have 1 million sessions, each one of my servers is going to have to keep around 1 million things. So in poll style metrics, you want to be very careful if you have very high cardinality things like session ID or request ID, just because you might not have enough resources to kind of keep those in memory. So if I start to think about like, if I were building an analytics kind of front end style application, I would probably go with derived or raw events. This is typically why these kind of like UI analytics systems are notoriously high load, right? They generate an insane amount of data, like every time a user does something, right, trigger an event. And so that's because the UI doesn't have a whole bunch of resources and it needs to send these things over. And there's just so many ways that you can like slice and dice your data. You probably want raw events, right? That gives you a little bit more flexibility to decide after the fact what you'd like to know, versus with derived events, you kind of only get exactly what you programmed into the application. And then similarly for like IoT devices that probably don't have a lot of resources, they probably want to just fire and forget and not have to keep the value of the thing that they store around. So that's just kind of the way that I reason about the trade-offs for these types of things. And so, okay, lots of words again. And you know, like how does this all really kind of connect back to red and things like this? And so I figure I'd kind of go through and maybe just give like a hypothetical kind of fake example and show a little bit of queries that get a little bit more complicated about like creating a red style set of metrics, defining some SLIs and some SLOs, service level indicators and objectives from these red style metrics, and then maybe we notice a problem with that. One of our things, we're violating an SLO or an SLI is particularly high. And so we can then use maybe like a use style metric to understand what is happening, maybe to get in some insight into an internal bottleneck in our system or something like that, right? So I can actually, in this example, I've used raw events, and the first part of this query here is computing the errors and the rate, and then from that I kind of join those things together to get the percentage of availability that I have, right? So I figure out how many errors I have, I figure out how many of the total rate I have, and I look at what percentage of the requests that I have errored, and I use that to define availability, right? So how much was I available to service work that came my way, which is great. I can then, so in this case, right, I can notice that I was at like 0 availability and then 70, and then I went to 100. And so something was maybe going on there. I might want to investigate that a little bit more. Another thing that I could do is I could set an SLO that says I will never have requests that take greater than 15 seconds, right? So if there's ever any requests that are taking more than 15 seconds, I'm in breach of my objective, and I want to kind of work to get that lowered. So in this case, I'm at 75% of my requests are greater than 15 seconds, which is totally a problem. So what I'm gonna wanna do, right, is maybe start to investigate that a little bit more. So I wanna think, okay, I know that there's this mutex that I have in my server. I wonder if it's under like a bunch of contention. And so what I can do is I can take this use kind of style of understanding, right, and think about, okay, what are the resources in my server, and I can start to look at the utilization, the saturation, and the errors associated with that resource. And so, you know, let's say I'm doing this mutex example, I can go through and add some metrics about the duration that it took to acquire the mutex, how much time is spent while the mutex holds the lock, and then how many times that the mutex was acquired, right? And I'll just put IDs for each of my mutexes so I can know which mutex is the one that is experiencing the problem. And I can then come up with this idea of utilization. And this is the exact same thing we had done when we did the pull style for red, right? Where conceptually what we're doing is just getting the values of how much time we spent waiting for the lock, or how much time we spent holding the lock, and dividing that by how many times we acquired the lock. And that gives us our average utilization. Again, in the real world, we probably want to look at things not just averages, but more percentiles or quantiles. But this will do for now. And so we can see some information here, right? I have a bunch of utilization, and it goes down, and then there's bunch, and it goes down. And then I could look at saturation, right? Which will be the exact same premise where I do that difference and then compute the average time that I end up spending waiting for the lock. And we can see it's very similar to the saturation. So that lets me know that this lock is particularly under contention and might be something that I want to start looking at if I'm doing any kind of optimization of my system. Cool. And so that's kind of mostly what I have here. I just want to talk about some kind of little pieces of conclusions or ways to go from here, or conclusions that come from this talk. I would say that you want to use a methodology when you're instrumenting your system. Read and use can be really great kind of starting points for getting you going, but you don't have to stick to those exactly. But I would encourage you to kind of be methodological and think in a methodology about how you're going to monitor your system and what you want to know about your system. And you know, you always kind of want to reason about trade-offs of different styles of metrics and find exactly what works for you or fits your particular use case. And the thing I think that's really compelling or interesting is in a lot of other query languages, you don't quite get the flexibility to make this decision about which metric style you want to use. And this is something, and even in V1 of InfluxDB, you really couldn't do. If you wanted to do any kind of processing with these values, you would really have to write them into the database, query them out with some query, and then do some transformation in your own programming language. I think what's really exciting is Flux doesn't dictate which metric style you have to use. You can really pick and choose and figure out what exactly works for you. And I think that's really compelling. And yeah, that's my talk. Hope that you enjoyed it. And if you have any questions, definitely feel like you can reach out and send me an email. I'm happy to answer any questions. We also have a community Slack, and I'm happy to respond to things there. So cool. Thank you very much.